In this video, we'll take a look at how IBM Netcool Operations Insight with Agile Service Manager can help manage our Black Friday shop, IBMSocks.com. This is based on the excellent Weaveworks Sock Shop demo and is running in IBM Cloud Private. Because we expect a huge number of orders, we want to use ICP to scale out our shop services, and we'll use ASM to verify the scale out, its status, and also see when new service elements are running. To do this, we're going to put ASM's UI into a mode that will let us easily track how the scale out behaves. So we enable an appropriate layout, we look at the timeline, we make sure that we've got an appropriate refresh, and now we're ready to scale out the service. Switching to the ICP Deployment Management UI, we'll switch to our shop's namespace and we'll scale out the front-end service, and we'll then switch back to ASM to verify that the scale out happens as expected. Switching back to ASM, we'll now watch how the scale out behaves now we've made the scale out request in ICP. The timeline will give us an insight into how the topology is changing relative to the front-end deployment. We're now getting notifications about topology changes as a result of ICP scaling up the front-end instance. Here we can see new pods and containers and where those containers are running as a result of the scale out. Now our shop's been scaled out and is live, we'll turn our attention to DNS. We hear time and time again from our customers how problems with DNS can wreak havoc with service availability and can be tough to troubleshoot. We'll take a look at how ASM's DNS management capabilities can provide operators with insight into how DNS is behaving relative to services that they're deploying in their environment. In this case, you can see an event that's been generated via ASM's APIs that's telling us that there's a potential problem with a time to live value on a particular DNS lookup. TTL values in DNS control how DNS servers cache data and how long they retain it for. Inappropriate TTL values can render services unavailable if the caches don't update quickly enough. So in this case, we'll go and fix the potential problem by changing it to use a much shorter TTL value instead of the default. We'll now see how ASM and NOI reflect the fix in both the topology and in the event list and ASM's status UIs. Going back to our shopper, we can see that they're still happily browsing the catalogue of socks that we provide. But we'll now take a look at one of the other aspects of DNS that can be challenging to manage. In this case, the operations team are checking our DNS server to see what IBMSocks.com resolves to. But let's assume that they've been tasked to redirect the traffic from IBMSocks.com to another system. And so they use their DNS management tool to go and change the IP address. But in this case, they make a mistake. They apply the mistake, and because we've got a low TTL, the changes are going to propagate through the DNS server hierarchy pretty quickly. So they're now verifying that the DNS change has been made appropriately, and our shopper is going to encounter a loss of service because that name no longer resolves to the appropriate IP address. But what we can do is make use of ASM's DNS management capabilities and APIs to generate notifications about how DNS has been changed and track DNS config changes over time. So in this case, we've got an event about a DNS change, and we can use the event and the ASM UI to do a comparison and show that the DNS entry for IBMSocks.com used to resolve to .42, now it resolves to .44, and we'll go and change that back. We'll go and fix the DNS problem by changing it back to .42, and the operator can easily see that reflected in the ASM topology. The operations team now do a further dig on the DNS server to make sure that the DNS entry is correct, and our shopper's shopping experience should be back to normal.